Hello and welcome back to another episode of Getting into Good Oxide. Welcome back, Sydney.
Hi, Sebastian.
And after a wonderful weekend, we are back with our ignored test here as the first test to trigger. Let's see what it triggers. To trigger that new Git object database lookup prefix function that, well, is supposed to, where everything is supposed to come together, all the prior work and packs and loose databases. And last time we spent a lot of time exploring and talking, but today I think we can get something done. All right, so this one should return none if there is a prefix that does not match at all. Okay. It works. Next. What can you do? And I think that just is in the vein of let's try to just have one more test that is actually a test, or that is more of a test, and then we have some proper motivation to do some more. And this one is more than one match. So that's the error case already, huh? So what about this one? Iterable objects can be looked up with varying prefix length. And this one iterates all the objects, and yeah, that's exactly that.
It looks like the one we want, so.
Yeah. Pop. The good value tries all kinds of length. And does that compile already? Yeah, that's fair. How is that called? DB with all object sources, right? If I recall correctly, that's also some temp directory that we get because we are building a multi-pack index on the fly. And now, yep. Ah, yeah, okay. So that...
You don't need this anymore?
Probably not. Ah, yeah, so that returns an iterator, but that creation can fail. And then, I don't know, is the individual item still an error potentially? Looks like it. And that makes sense, right? That the individual item can still be an error because we do have loose databases there. And these loose object databases could error at any time. It's a bit sad that...
So this is carried through for the rest as well?
Yes. And I think it's a bit sad that 99.9% of the objects are not going to need this. Or let's say that only at some points in time, maybe you need this, but then you've got millions of objects that won't ever possibly error, but you still have to deal with it. But that's just how it is. That's programming, I guess.
Yeah.
You can't forget it in Rust. You have to do it. And it's good. It's for the better. And it runs into our... It already runs into this issue that there is no exterior error, but we would expect the object to exist, which makes sense. Okay. So we do have an error case here. And this makes me think that I want to copy paste from a function or method that also has an error here. And just copy things around from there and adjust things from there. So we have this.
Oh, I see. Okay. Yeah. Just as a raw skeleton, basically.
Skeleton, yeah. And rather remove code that we don't need than to have to add code that is related to error handling. And inherit these to-dos and these messages that say, I really want an error here, but the API, the trait does not allow that yet. Okay, we've got an outer loop, and then we get our snapshot mutably. So borrow mud, that's a function or a method of the ref cell here. Whenever you see ref cells, you know interior mutability.
Mm-hmm.
And you know not sync. Not sync. I wanted to see if I can show this somehow, the not sync part. Yeah, there. See? So everything with the ref cell is explicitly not sync.
Mm-hmm.
And that is propagated through the hierarchy of things. So somewhere nested deeply in some data structure is a ref cell. The whole data structure is not sync. And that's done at compile time, so you cannot share this thing across threads anymore at all. And that makes sense, right? Because these things, they allow you to be mutable without officially being mutable. Like I can mutably borrow stuff, but that only takes an immutable reference. And you see how easy it is to violate rules about mutability and, only one writer at a time if you have threads coming in, because they can totally then do strange things with each other if that would be allowed. So yeah, not sync makes total sense. It's perfectly safe in a single threaded setting though. Because the only way to make this fail or panic is if, code elsewhere tries to do the same, but that code is called by us. Like we are serial here, right? So if I make a mistake, then I could possibly call this again and then it will panic. That's fair.
Mm-hmm.
Okay, so once you have this snapshot, we do iterate all indices that are currently there in a mutable fashion. And then, maybe that's something to refactor here. It's like, what? Oh yeah, it's a lookup. We look up the ID. And this would now be lookup prefix. Okay. Because we only have a prefix, and that's where we start hooking up this strange index here, whatever it is. Like, I don't know. So it's this index lookup structure that is there just for looking up indices, and it hides what kind of index it is. And this one should definitely expose something to look up prefixes. And then we have to see what we get here. I don't know what that is. It's probably the prefix itself. Like, I think that this is more akin to this here. Option result, something like it. Maybe, yeah, an option result, because the lookup prefix of packs, that's that. And that's the only thing they expose.
Okay, so, but shouldn't we, like, is this lookup prefix only meant for pack files?
Yes.
Or is this also like, okay.
Yes.
I thought this was kind of combining all of the different things in one, but that's not the case here.
Yeah, this is, you're totally right. It combines two kinds of indices, like the normal one and the multi-pack index. So it does have this role, but it's really only related to packs and the pack index. This is,
okay.
Yeah, I know this term indices, right? It means kind of so many things, and in Git Oxide, it tries to really only mean a pack index. And usually it does. Otherwise,
that's totally fine then.
yes.
I just thought that we need the result as well because it's a loose object database, but I'm guessing that comes further down.
Yes, let's go further down just to take a look. Here's the loose ones.
Right, okay.
And that's real loose object databases. So here we can already do lookup prefix. And that already works as before.
Mm-hmm.
And all this craft here is really something we probably have to cut back on. Like, we already kind of know what this is supposed to be. I mean, if I sketch this, sum okay. Oh no, we don't. Because we have to ask for everything. It's more like if any of these, yeah. So if we have found one already, something like this, then the next time we find one, we have to error out.
Yes.
And that one that we find is in fact more like a candidate because we have to remember that one because that's the object ID usually. Or the entry index could also be the index. Yeah. So yeah, I think that helps. Because we know this must be an option get hash object ID. That must be the one resolved object. And we know that these indices, they return an entry index, which we can then use to look up the object ID. Here, this is something that I'd say we don't really need. It would be much more useful to have the actual object ID right away here instead of some index.
Mm-hmm.
Because if we get this one again, and if candidate is already sum, then we know we got a bail with okay sum error, which indicates no strange error during lookup. We found something, but we found too many, ambiguous.
That makes sense, yeah.
And then if you get here, this would mean that candidate is none, just by inference, so to say.
Mm-hmm.
And we can just assign the candidate that object ID and continue. I'll just explicitly continue here from now, just because I don't know what's underneath yet, except for a lot of stuff we probably don't need. And this marker stuff too. Yeah, let's see about that. Let's clean this up. Okay, then we have some error. Yeah, this OID we don't actually use. Or, like if this is an error, if this is some error, then we know this is ambiguous, right? So if it's ambiguous there. Okay, so we have a candidate or it's ambiguous anyway. Then first time we see a candidate. And now we have some okay, we have some error. And now we have none. And none just means continue. Yeah, keep looking.
Because we still have to go through the subjects.
Yeah, we have to go through.
Or it hasn't reached the end yet. Yes.
Yes, go through all the packs. And then eventually you will end up at the loose objects. Let's see all this, possibly pack, yada yada, load one index. The thing is, we at some point have to get the code where we load indices. That's still there, that's good. Further down. And this is all related to packs. And packs we don't have because we don't look up objects. We don't have to deal with dynamic loading of packs and whatnot, and all this complexity goes away. And that's
so. We have this one candidate up there, right, that we assign if we find something. But you said that there can be duplicates, and we test for that, right? There can be overlap in the loose object database and in the pack files. Do we have to deal with that as well?
Yeah, great catch. Great catch. Because not every candidate is the same, right? So if the candidate is just the same thing, then we can continue.
Okay. Yeah, exactly. If it's exactly the same, then we know it's a duplicate and we ignore it. Yeah.
Okay. So now we want this OID again. This. Okay, so now we changed the rules a bit. I don't know if that's the right thing to do. I just know this will give us nicer access to the candidate itself. So if we have a candidate already, and if the candidate is not the object ID, or we have an error, then we return the error. Okay. And if we have this, if candidate is OID, then we can continue. Yes. And we are back from a little break, and a lot of stuff happened while we hit the pause button here. But yeah, actually while implementing the thing, I did notice a little issue with the snapshots here, which can easily be fixed in the sense of I asked the ref cell way too often to get me the mutable content to it. And I think that's not necessary. Even though we continuously reassign the snapshot or get, more recent versions of it, there's no need to ask the ref cell so often. And so far, these refactorings work just fine. All tests are still green, and that's really nice.
Good.
And here, back to the actual gist of it. I mean, here the snapshot can also move up. We iterate indices. We do hopefully the right logic with the candidates. And then, oh, this is still very unhappy. Why is this so unhappy? Use of moved value because of this, I guess. Here we can make the fix as well. This is how I got the idea of doing this in the first place. And now everything is happy. And this is mut. Ah yeah, so by the way, that's also interesting. Like, this is a mutable snapshot just because we expect it to be reassigned later. But that might not actually happen because we are read-only here. We don't actually have to change anything. The snapshot usually is mutable because we swap some content. Like if we find an object in a particular index, then we make sure that this index is in front then. So we basically make follow-up objects that are in the same index easier to find. But for prefix searches, that makes no sense. So we have to search everything anyway. So no need for this to be mutable. This can be immutable. So we just borrow it so that we get access to it. And same here, just mutable. But here then, now we have to drop the previous mutable snapshot so that we are able to get the immutable snapshot to assign. To assign the new snapshot to. And in the next iteration, we just get a new immutable one. And this is how this is supposed to work. And this load one index, it basically keeps loading indices until we are done. And I think this also needs an overhaul, like, because here we should return our candidate if we have one.
Oh yeah, okay. So that means if it stops loading new indices, then we know we're done basically.
Yes. And we always bail out early for ambiguity. This means here we have potentially some candidate and we have to return okay, some okay. So that's the type. You see we wrote this before. We wrote this in lose object, I think. Or somewhere, I remember it anyway. Probably the search and all finds remembers it too. See, lose object, okay. So that's the way. And here is where we can now say, yes, there's nothing new to load. So the whole database was loaded, everything, every index, every loose object. And we tell it to never refresh. Refresh means load new stuff from disk. Like check if the disk changed.
So, okay, that's while we do all of this, all of the lookup, while if during that something changes, it should load more. Yeah. But in this case, we don't want it.
But actually, I think that's wrong because we might not find a prefix because something changed on disk. And then we want to refresh it once and see what changed on disk and then keep going, because that will also return none if nothing changed on disk. So you tell it, okay, everything is loaded, keep looking. And then if the refresh mode, which is usually pre-configured to be after all indices loaded, once everything is loaded, it will look on disk if something new comes up. And if not, we get this.
We're done.
Yes. So if you expect, that's the thing, like this could be slow if that gets hit a lot. Like if there's lots of objects that don't exist actually. But it's okay. I mean, that's the correct way to do it. Just leave it as is. Because usually...
I mean, when would that happen? Like, in what case would it actually change? Or in what case would the file system change?
Yeah, if you repack... Yeah, that's the thing. Like, usually only objects are added. And, I mean, there are scenarios when a new pack was just downloaded and somebody asks you about that object in the new pack right away with the short ID, right? Like, who does that? Only users do that, and they don't usually, I don't know, but let's just say that's the correct way to do it, because usually that will look on disk if something changed and you pay the price for that. Usually, yeah, wait, I think I'm missing something. I have the feeling that because we can only ever return something once we get here. So we always trigger, for each short ID, we at least trigger a refresh once. Because we can't early return the object ID, like all these previous lookups, they always say, hey, I found it, great, return what you searched. But this one here is to keep looking and make sure everything is loaded. And then is really the question, like, should it be allowed to refresh the disk or not? And I think last time I was already kind of predicting this and said, this should be refresh mode. Never. So that it will never reload from disk. And what you have to know is that when you instantiate this object database, it memorizes the whole disk state. It knows all the packs that are on disks, and it just knows the possible set of things to look through, even though it doesn't load any of them. And this set is what might get reloaded if we don't put this to never. Then it looks at the whole disk state again, and maybe there's something new, maybe not. Most of the time not. And then you basically just pay a lot for each short ID because we don't pay a lot early, right? We do the opposite. We kind of want to get here so that we know it's done. And this will also load all the indices in the object database because we have to. Okay. But this, this could also be wrong under circumstances. Like if really something new happened and this is a long running process, then this would not be able to find new packs because it's not allowed to find them. And I don't know. Either you pay always, then you get the right thing, but you always, for each short ID looked up, you always have to touch disk, and that seems very slow, And that's definitely something that Git isn't doing. So I don't know. Never is definitely fast, but also, yeah, you know what? I think I'm making a mistake here. So everything I said is correct, but there's a reason this is something that the user can configure. Look, pub refresh mode. So the one owning the handle can decide how to do that. And that's the point. It's, if you know that you're a long running process, then you probably keep the refresh mode to auto refresh. But if you know you're just a command line tool like Git, you come up, you load this thing once, short ID, and you're done. You don't need to check again because
exactly. In worst case,
the user runs it again or something. Yeah. You can always say, well, the file wasn't there yet when I ran in that 10 millisecond time window, right? Because you're fast. So this is why you just do it like this, but it's worth considering. Wait, so refresh mode. Yeah, right. We don't use that anymore. Okay, cool. So now it's just the same. So this thing still fails. Object exists because we don't look into loose object databases. Okay, now the logic again. Let's see if you can get it together.
So we started with both existing, right? And then with the if condition. If they are not the same.
Some candidate if OID isn't candidate.
Yeah, then this is the ambiguous case.
Return okay some error.
Nice translating. Yeah, then the same case again without the if. Yeah, that would just be then continue.
Candidate. Oh, come on, what did I do? Ah, there. parenthesis. For as long as I can think, I wouldn't mess these up.
And I just wonder, I mean, before we spelled it out, and we did that for a good reason, but couldn't we also just kind of do the catch-all cases here, because we know the rest are all, they're all end in continue, right?
Once we assign something.
Okay. Except for this one, of course.
And there's another error case. Yeah, but you're right, there might be some way to fold these in so that all the continue cases, for example, are together. So this should work. And here, but you see, is there anything else that can be folded? Return, yeah, these two we tried, right? But we could not.
Yeah, that doesn't really work.
And yeah, good enough. I guess it's fair to just accelerate this and say this is awesome. That's as good as it gets. Copy paste. Should be the same thing. And does it work? What? Something with variable is not in all patterns. Yeah. So now I copy pasted something that doesn't actually work. Yeah, so it's always nice to be able to describe things with an underscore, but in this case, you must ignore it like this, which probably also makes it more readable. Otherwise, it wants you to, it binds these variables, even though they're, unused. The underscore is just, it doesn't matter. It's still something you can use. You bind the value to this variable, but you don't do this in all patterns. And even though you don't use it, it's still an error from Rust's point of view.
Okay.
So I think in future versions, you could say, yeah, well, you don't use it and you want to describe what's in there. Fine, do it. I don't care. You can do that. But right now, it doesn't allow you to do that. Should work, right? But it doesn't. Okay. And now, so there is a walk deer error that is not implemented for dynamic error. And that's a bit strange here, because don't we do that somewhere? Probably not. Okay, fine. There's a lose find error, and there should be a lose walk deer error. Lose. What's that called? Good features. Oh wow. Good features of S walk deer error. Let's check if that's the actual error. How do I get to the error type? So that's a bit unintuitive now. Now I don't find it. So create lose iter error. That should be, that makes sense. That's something we should be finding. And that just redirects to that actual walk the error. That's fair. But I don't want to use this one here, but that one. Okay. And that occurred while looking for the prefix, which requires iteration. Okay. And now what? Candidate isn't Oh yeah, this one should be that. And that's also something, I think it's my mistake, because candidate, that's actually copy, because object ID implements copy. So I don't have to take the reference here, I can just do this and then not bother. So if types are copied and somebody decided for you that it's okay to copy them,
And you should use it.
and you just use it. Let the compiler do the rest. Unambiguous. Okay.
Getting somewhere, I think.
So we found the object, but we think it's ambiguous. And that's strange. Because that should not happen. Like, we can have duplicates, but ambiguity, not really. But then again, do we know? Yeah, we know this database here. We know that.
Yeah, I think we do.
I think 4 is okay, right? Or is, like, maybe the test is actually underestimating something. Can I go there? No, I can't go there. I think I can jump here somewhere. It's amazing. I'm really, here, there. Okay. So that's my only guess. Let's put this to 7. Is there some? Wow. Okay. Never mind. So 4 is ambiguous. 5 might be working here. Okay. Cool. Now we can quickly get this thing to run and then validate. It's interesting. We do a lot to make this ambiguous. But I think we copied this from the loose object database, which is indeed not really having ambiguity there or something. I don't know. I'm just saying, we don't have to do it like this here. Because we know it's ambiguous with 4, and we can just test that. We should probably print.
In this case, yeah.
Yeah. And also have to figure out what's ambiguous there, and we don't know that yet. But 4 characters are ambiguous, so I guess the whole preamble, remove, hex to ID, something that we have to still find out. And then this should be 2 objects with that prefix. Let's try. Yeah, I would just, print out all the IDs that are in there and see what happens. And they're not necessarily returned in a sorted fashion, so let's do that. So store. Do I call it store and the other ones too? Yes, I do. Okay. Either collect. Interesting. What's this? Result. Like this. Okay. It's a bit of a strange way to write that. Usually you write it like this.
Oh.
Because we know we can, like, each of these things that you iterate over could fail.
Mm-hmm.
And I think that returns object IDs. Does it? All objects. Object IDs, owned object IDs, exactly. Now we sort. And now we print. And let's see what ID we find here. Wait, so this test is running and it's actually failing. Really? What? Wait. So it's succeeding, I mean. Like this test is running and it's succeeding. And
And then it's not printing.
I do not see the printout, even though I should. So that's a bit strange. Okay, prefix. Oh, it's still running. Interest. Is it really running? Okay. Sometimes IntelliJ thinks it's running, but it's not actually running. So this one isn't. And I don't know if I can just, if I see more now. Look, it's terminated. Like this thing, 34 out of 54, this thing crashes somehow. What's going on? What? It crashes, but IntelliJ, here, look at prefix match event failed. Ah, that's IntelliJ having some issue. It receives the data here from the test suite and it prints stuff, but it fails to interpret the data somehow.
Can't deal with it, okay.
Can't deal with it. Git ODB cargo test. Okay, see, so that's more like it. Oh. So now we're looking for prefixes by hand here, huh? Four or more. And we know there was one.
Oh, here, A706, A706. Right at the bottom.
Oh yeah. That's the one.
One of the ones, we don't know.
Yeah. A706. Good catch. Let me copy that again. I have a feeling I didn't get it all. And that might be it. Cool. And it's green and now it prints it out. So you see how IntelliJ thought the test is still running because something there failed and the error wasn't propagated properly. So error handling fail, I think, on IntelliJ's side somewhere. That should not be possible. But it is, because type system probably not strong enough. Okay, well. Cool. So that's the test. Wow, look at that. It looks like it's implemented. We have ambiguity. We have all kinds of different lengths that are non-ambiguous. Can't find it all.
Looking pretty good.
Yeah. And the object ID that we find is the object ID that we pass into the prefix. And looks pretty good to me too. Yeah. Awesome.
Cool. So that means we can now find at least find out if a prefix is ambiguous in a repository or in an ODB.
Next one is short ID. To actually find the first non-ambiguous short ID, and that's a hint more or less. This is the object ID that we want to shorten. It's more like shorten ID. Given this ID, make it as short as hexlang or longer if you have to.
Oh, yeah, of course. That was the special case, basically, like, okay, how short can this be?
Yes.
Or, yes, try to make it this length. That's what we need for Bergen.
Yeah, that's what we need for Bergen, but we need it on the highest level so that the Git repository gives you this and it pre-configures the hex lang with the config.
Mhm.
I don't know if she wants to tell me something with that. I should probably be insulted. Look, Daddy, for all the shit you write, have a diaper. Okay, this is not shit. This is Rust. This is the good stuff. Okay, wait for it until
We're
you
getting
learn
somewhere.
it. Yeah, runs, works, great. I'm happy. That could be it for today.
Sounds good. Then next time, yeah, we see how far we get with the short ID or shorten ID. Then
I thank everybody for watching and see you next time for short ID or shorten ID. Bye bye.
Bye bye.